All right, back again here for section 9.8, which is all about the Pythagorean theorem and space figures. So what that means is we're going to be dealing with some shapes that are in 3 dimensions. So the 2 distinct type of shapes that we're going to be talking about are the rectangular solid and the square pyramid, regular square pyramid. All right, so let's get down to business here about the rectangular solid, things that you need to know. First of all, the faces of your solid are all of these rectangles. So you have a rectangle on the top, on the bottom, on the ends, and in the front, and then in the back. Those are all your faces. Okay? Then we have edges. Edges are all these segments that make up the faces. Okay? So all of these segments there that make up the rectangles are called edges. Diagonals, now where they're talking about the diagonal of a solid, not the diagonal of a face. So here is an example, HB, this segment right here that travels through the interior of our solid. That is the diagonal of the solid. There's actually 4 diagonals in this solid, one starting from each of these 4 corners. So if I started from G, up here, I'm going to go through the solid all the way down to A over here. If I start at E, I'm going to go through the solid all the way to point C. And if I started at F, I'm going to go all the way through the solid to point D. Okay, so those are the 4 diagonals of a rectangular solid. So then we go over here to the regular square pyramid, and you're going to have a base of your pyramid, and typically pyramids can have any shape base, but we're going to be primarily dealing with square bases. Okay. There's a vertex, this point all the way up here where all the sides of the pyramid meet. So that's point P. You have an altitude. The altitude starts at the vertex and goes down, so it's perpendicular to the base. And it's going to be at the center of the base, okay, because these are regular pyramids, they're not slanted. Okay, and then we have a slant height. So in a pyramid is made up of a bunch of triangles all leaning in towards each other where they intersect here at point P. So each triangle has its own altitude. And the altitude of the triangle is called the slant height. So this segment here from the vertex to the midpoint of this side is called the slant height. And what you need to be aware of is that since this is the altitude of the triangle, it is going to form a right angle. They're perpendicular. So this rate, ooh, that was bad. That right there is supposed to be a right angle. Sorry, I'll try that again. Let's see if I can do this better. Better. Okay, so there's a right angle. So when you look at these triangles, there's a lot of triangles. There's triangle PSM. Well, that's a right triangle. Okay. There's also triangle PSK. That's also a right triangle, and those 2 triangles are congruent to each other. But if you take into consideration the slant height and the altitude of the pyramid, these 2 sides when you connect the center down here to the midpoint, form a right angle as well, or form a right triangle. So this is a right triangle right here. So there's a lot of right triangles within this pyramid, and depending on the information they give you, they're going to ask you to find specific sides. Okay, so that's what we're going to be doing in this section. Okay, let's do an example. First one, given the rectangular solid with the dimensions 3 meters by 4 meters by 12 meters, find HB. And we can see HB is the diagonal. Okay, now they didn't tell us specifically which one is length, which one is height, and which one is width. And that doesn't matter because they're just 3 dimensions. So we're going to place them wherever we want. So the 3 and the 4, since those are a lot smaller than the 12, I think those are going to go in this spot and this spot. So we have a length and a width. And we'll leave the 12 for the height. Okay, So if we fill those in, I called this 3, I'm going to call that 4, and then I'm going to call the height 12. Okay. Now, if this is 3, that's also going to be 3. And if this is 4, then that's also going to be 4. And if this is 12, that's 12. And you can do that all going all the way around. So we have a lot of congruent segments here in this rectangular solid. Okay, so what we're trying to do is we're going to try to find the length of HB. So some of you probably already solved this in your head. Others might not know what to do first. But the first thing we are going to do is we're going to connect D and B together and make a diagonal. Because what that allows us to do is down here, since this itself is a rectangle, this is a right angle. So we end up having a right triangle with side 4 and side 3. DB ends up being the hypotenuse. So using our 3, 4, 5 triangle, I know that DB has a length of 5. Now, once again, what you have to be aware of is that we do have a right angle right here. Okay, it looks weird, it doesn't look like it's a right angle, but it really is because this is standing up. So HD is perpendicular with this whole base. So right here, this makes a right angle HDB. So if that's a right angle, this HB is the hypotenuse. And if this is 5 and that's 12, using our Pythagorean triples, we know that that's going to be 13. So we now know that the length of HB is going to be 13 units, or I guess it's meters. Okay, so that's how you're going to be dealing with your rectangular solids. First find one diagonal, and then find the actual diagonal of the solid. And sometimes these are going to be families. Sometimes maybe this is a square, and so you have a 45, 45, 90 triangle, and you'll use those relationships. Okay? All right, let's see, the next one. Oh, I should probably erase those into, yes, there we go. All right, so in this particular problem, it says given the perimeter of JKMO is 40 and the length PK is 13, find PS, which is our slant height, and PR, which is our altitude. So first of all, this is a regular square pyramid. So this base is a square, and if the perimeter is 40, we know each side is going to measure 10. I'm not going to write the 10s in the background because it's going to get a little messy and crowded there. But suffice it to say, all 4 of these segments are 10. Okay, next thing, we know that if this is 10, when you drop down PS, which is the altitude, it's going to break this up into 2 equal parts. So both of these are going to have a length of 5. All right, awesome. Next, they tell us that PK is 13. So that means this right here is 13. So remember how I said this is going to be a right angle. So right here, this is a right triangle, and we have a 5 and a 13. So using our triples, we now know that PS is going to measure 12. So that was the first one it asked us to do, is to find PS. Now, the next thing we have to do is figure out what PR is. Well, PR is right here. So we're going to be dealing with this triangle that I have highlighted kind of in blue. It's also a right triangle. This right here is a right angle. And what you have to also remember is that this is the center. So this length is going to be half of this entire side. So this length is also 5 units. Let's go ahead and call PR X. So now we have X, 5, and 12 to solve. And a lot of you might be thinking, oh, X is 13 because you have the 5 and the 12. But remember, the 13 has to be on the hypotenuse. That's not going to work. So we actually have to use the Pythagorean theorem. So 5 squared plus x squared equals 12 squared. We'll go ahead and solve that, and we get x is the square root of 119. All right, there you have it. You're going to have some problems to do with rectangular solids and pyramids. Hopefully that won't be too hard. I hope it's not difficult to see the 3-dimensional shapes. Just plug in all the numbers where they go. Make sure you write in the right angle symbols if that helps you to visualize the right triangles and see which one is the hypotenuse. Okay, we are done. Good luck.